Okay, let's continue with the second part of the problem set. Here we have a scenario where we have to work with cost function. We need to take the derivatives, and we probably also have to program something in Excel and visualize it. So assume you produce cookies x with the total cost function, which is total cost equals 0.1 x cubed minus 1.25 x squared plus 7x plus 5. So the 5 doesn't have an x to it, so that's obviously independent of output, so that must be the fixed cost. Because if you don't produce anything and x equals 0, you still have total cost of 5, so that must be the fixed cost. So now we know that they have an inversely S-shaped shape. So we have here x, and then there is this part which is fixed, so that's fixed cost, and on top of it we have the total variable cost, and that should give us a function like this. So initially output increases at diminishing rates, but then it goes up. So this is this inversely shaped S-shaped total cost function. So again, initially production grows faster than the cost, because the people that we hire to produce something, they become more and more productive, but then eventually, after they exhausted their specialization gains, they start standing on each other's feet and they become less and less productive. And if my kitchen is already full, I can hire another person, but I will not generate more output, but my total cost go up. So in this case, if you take a look at the marginal cost, which is the derivative, the slope at each point on the curve. So initially it's pretty steep, and then it gets flatter. Maybe there's a point of inflection, and then it picks up again. So we already know that the marginal cost function is obviously U-shaped. So marginal cost looks something like this. Whereas maybe here is the minimum, like a minimum here. Okay, so then we have a utility function, and we know a utility function should increase at diminishing rates. So we have here x, total utility, and it should be something like this. And here if we take a look at the marginal, we see initially the slope is really high. That means if we increase consumption by a little bit, then we get a lot of utility. But when we already have a lot, the extra utility from having another cookie is not that great. So that is, so if we draw this marginal utility, then we get something that looks like this. So what's now important is just taking a look at the lower ones, the lower two graphs, because we know that you maximize your utility where the marginal utility equals the marginal cost. You know, if the next cookie gives you more utility than what you have to pay for it, of course you'll have it. But the more cookies you have, the lower will be the extra utility, and maybe the cost eventually go up if you produce them. So now what we need to do is we need to look at marginal utility and marginal cost in one graph. So the lower two graphs, I put them into one. Okay, so now we have here the marginal utility and the marginal cost. So maybe I give the marginal utility, I do that in green, so that's the marginal utility, and then maybe a marginal cost in red. So now we know that here the extra utility is greater than the extra cost, so you have it. So you consume more and more and more. but the profit maximizing or the utility maximizing point is here, that X star, where the marginal utility equals the marginal cost. And it doesn't make sense to go beyond X star, because why would you have another cookie that you value at maybe $1, but you would have to pay $2 for it? That doesn't make sense. Okay, so now we have to actually look at those two equations, and we know that the marginal cost function is the first derivative of the total cost function. So the marginal cost is equal to the first derivative of the total cost function with respect to x. Okay, so let's do that. Let's take the derivative. So as you know, we start with the exponent that goes in front. So now we have 3 times 0.1, which is 0.3 times x. But then in the next step we have to subtract from the 3 the exponent 1. So we are left with a squared. Then the next term we have a minus. So we take again the exponent, put it in front. So now we have 2 times negative 1.25, so that's negative 2.5 x, but now we have to subtract from that 2, it's actually a 2, we have to subtract negative 1, so we are left with a 1, but that 1 is typically invisible. So now we move to the next term plus. So here we have an invisible 1, x raised to the 1. So the 1 goes in front, we have 7 times 1. So that stays a 7. But then we have to subtract again the 1. So that becomes 0. Something raised to the 0 is 1, so it just stays 7. And the 5 doesn't have an x to it, so that becomes 0 too. So the marginal cost function is 0.3x squared minus 2.5x plus 7. So this marginal cost function would be something like this here. So now let's move to the utility function. The utility function is here. So we start also again. So the marginal utility is the derivative of the utility function with respect to x. Okay, so we have, I'll just take a look at this one here. So we take this 1/2. So we can write it 22 times x raised to the 1/2, which is exactly the same as 22 times the square root of x. So something raising something to 0.5 is taking the square root. Okay, so the 1/2 goes in front, so we have now 1/2 times 22, that's 11, times x, and then we have to subtract here the 1, so we get negative 1 point, negative raised to the negative 1/2, and that can be written as 11 over the square root of x. So whenever you see something like, for example, x raised to the negative 2, for example, that would be 1 over x squared. So that's just to refresh again some of the calculus. Okay, so this is 11 over the square root of x. Okay, so now we already have quite a lot. So we can actually answer maybe the first question. So what is the marginal cost function? So it's the 0.3x squared minus 2.5x plus 7. So this is correct. Okay. What is the marginal utility function? It could be the first one is correct, but also the second, so it's both A and B. Okay, so now let's move to Excel and draw everything. So we still have a couple of questions, and those questions refer to what is the optimum choice here. Okay, so the way we can do it is to say, so how do we solve this problem? We can say your net utility is, I called it NU. Your net utility is equal to your total utility minus total cost. Okay, so your total utility is 22 times the square root of x, and now minus the total cost, and the total cost was negative, so we have to subtract the 0.1 x cubed minus the 1.25, but actually this becomes a plus. Okay, make sure that I need more space here. Okay, so your net utility is your total utility minus total cost, right? So your total utility is 22 times the square root of x. Okay, so now minus, now I put parentheses, and now we put the total cost function there. So 0.1 x cubed minus 1.25 x squared plus 7x plus 5. So we try to maximize this one. So we have some kind of a function that has a maximum, and that looks something like the net utility, and here we have x. So that is some function that looks like this and has a maximum, and a maximum is where the first order condition is such that the first derivative equals to 0, so the slope there is 0. So we take basically the first derivative of the total utility. We already have this. We said this is equal to 11 over the square root of x. That's the marginal utility, because if we take the derivative of the net utility, then this is basically, the first derivative is the marginal utility minus marginal cost, and that has to be equal to 0. Okay, so now if we take the first derivative, so this part is 11 over the square root of x, and then we have the marginal cost, which is the second part, and we said this is equal to, let's put again bracket, 0.3 x squared minus 2.5 x plus, it was minus 2.5 x plus 7. Okay, that has to be equal to 0, because that would be the first derivative of this net utility function, or if we say the 11 over the square root of x, that's the marginal utility, and the second part is equal to the marginal cost, and they have to be equal. So if we subtract one from the other, it needs to be 0. Okay, so now we can say again that we need to solve, in order to find the optimum, we need to solve 11 over the square root of x minus 0.3 x squared. So now we have here a minus times a minus, so that becomes a plus, 2.5x minus, but there's this plus, so minus 7. That needs to be equal to 0. So if we want to find the optimum x, that is the condition that we need to solve. Okay, and this is what we can do in GoalSeek. Maybe you can solve it manually, but from looking at it, that's not easy. So that is where computers come in handy. And let's do that in Excel. So let me quickly snip that out. So I'll just take this one here. That's the condition. Okay, so now let's open Excel. And maybe we can. So this is what we need. Okay, and now we can use GoalSeek. So let's say, so we have an x, and we need the output. We need the output to be equal to 0. Maybe I can. Okay, so let's say x is 1, then the output is, okay, then the output is equal to 11 divided by the square root of x, and the x is here. Okay, and actually I can activate also again my keystroke. Let me do that quickly. Okay, I turned on my keystroke recorder. Okay, so let's do it again. So let's delete this here. Okay, so let's say x is 1. What is the output? Well, in this case, it's probably not 0, but it is 11 divided by the square root of x, which is now 1, minus 0.3 times x squared plus 2.5 times x minus 7. Okay, so that's 6.2. So now I could play around and try many different values like 2 and see when does it get 0. Okay, 5, 6, maybe 7. That's pretty close. 8 gets more again, 9. So it looks like that something in the range of 7 gives us the optimum. But in practice, you don't want to play around with solving an equation like this by punching in all those different values yourself, but you tell Excel to do it for you. So the way to do it is we go to Data, then we go to What If Analysis, GoalSeek, and then it becomes straightforward. So it asks you set the cell. That's the output cell. So that is here cell L9. And we want to set that to the value of 0 by changing that cell. So that is like when I earlier tried different values, that is now what Excel does much faster. Okay, now if we see what we get. Okay, so it looks like that the answer is 6.97, so that's basically 7. So if we delete or remove some decimals, we see rounded it is 7 and 0. Okay, so the optimum output should be 7. Okay, so let's go back to using Excel's goal seek, we would say 7 is the correct result. Okay, let's also draw it just to see whether we can replicate a graph like this. So I'll just create first the X, and I do that from 0 to 10 because the optimum seems to be 7, so 10 is enough. 0, and I create again an x-axis that has a step value of let's say 0.1. So what I do is I highlight the entire column, then we go to home, and then there is something called fill series. So we go to fill series 0.1, the stop value is 10. Okay, so now we have all the x's, and so now we need the marginal utility and the marginal cost, and then we can have total utility and total cost. Okay, so I remember the marginal utility was equal to 11 divided by the square root Okay, now I will get an error, but that's okay, because beginning from 0.1 there won't be an error anymore. So now I'll just copy this down. You can do that by clicking into this little square, double click, and then I'll just say this is a number which is not available in A. Okay, the marginal cost was, actually let's go back to (0.3x squared minus 2.5x plus 7). Okay, so that was equal to 0.3 times x squared minus 2.5 times x plus 7. Okay, was that correct? Double check. 0.3 correct. Okay, now we have marginal cost. And now let's take a look. If I tell Excel to put x on the x-axis and display the marginal utility and the marginal cost, what we should see is a graph similar to this one here. And the two lines should intersect close to 7. Okay, let's do that next. Let's draw this. So I highlight first everything, and then we go to Insert, Recommended Charts, and then it's the second that looks pretty good. Okay, so we can actually nicify that graph a little bit. The axis doesn't look too good, so let's format that. And so first of all, we want everything on the tick marks. Maybe we want to have the tick marks a little bit spaced, maybe 10, and the labels also spaced out. Okay, now it looks a little bit better. So, and you can see indeed the optimum where the marginal utility intersects with the marginal cost, that is indeed close to 7. So it looks like we did everything correct. Okay, so now in order to answer the final question, let's also add the total cost and the total utility. So the total cost function was 0.1, okay, x cubed equals 0.1 times x cubed minus 1.25 times x squared plus 7 times x plus 5. Okay, so if we don't produce anything, we have total cost of 5, which makes sense. Okay, so now let's copy down this one. And the total utility, that was equal to 22 divided by the square root of x. So now we get again an error, but that's because we can't divide by 0. And we'll just say again, number NA. Okay, so now we can answer the other questions. Let's see what those were. So now we know the optimum was 7. What is the total cost when you produce x star, which is 7? So at 7, maybe we have to freeze the first pane. Maybe view, freeze panes, freeze top row. Okay, so when we have 7, the total cost is, I think we should round to 1 digit. So, okay, so then total cost at 7 is 27.1. Is that one of the answers? Yeah, what is the total cost? That's 27.1. What is the total utility when you produce the optimum number, which is 7? So let's go, total utility is 8.3. That doesn't look right, there's something wrong. 22, total utility square root. It's not divided. I thought I was still with the marginal. I'm sorry, I just thought it can't be right. I'm sorry, because this should be not divided by, but times. So now it makes sense. So now, because the total utility function was 22 times the square root of x, but the marginal utility was 11 divided. Okay, so I apologize, but now it looks correct. So now we can look up the optimum value at 7, so that's 58.2. Well, the good thing is, if I don't enter the right formula, we shouldn't see the correct answer here. So it's 58.2. And then the final question, what is the net utility when you produce x star, which is the total utility of 58.2 minus 27.1. So that is, if you subtract from the total utility, 0.1, 58.1, then 51.1 should be 31.1. Okay, so that's it. And so now we hopefully have a little bit of a feeling for how economists work and what are important tools in the way we think. And yeah, I hope it wasn't too complicated, and I also hope you enjoyed a little bit seeing the opportunities to work with Excel. But that's it for the foundations of economics, and we'll just continue now with the next chapter, which is specialization and the gains from trade, which also should be fun. Okay, I'll see you then in the next lecture.